How secure is Linux really? If you're using a standard distribution such as Fedora, Debian, or Arch Linux, you probably think you have great security. While desktop Linux is still a viable option, it currently falls significantly behind alternatives like macOS and Android in several areas. Secure boot on Linux is not as robust as alternatives such as Apple's Secure Boot or Android's Verified Boot. Secure boot prevents persistent tampering by malware and evil-made attacks. While it is present on some Linux distributions, it doesn't offer the same level of protection compared to Windows or macOS. Strong sandboxing for apps on Linux is severely lacking, even with package formats like Flatpaks or sandboxing solutions like FireJail. Flatpak integrates Bubble Wrap, which is the most promising sandboxing utility for Linux thus far, but is still deficient in many areas and allows for unsafe defaults, which permit most apps to trivially bypass its sandbox. While it's true that Linux could improve its support for secure boot and sandboxing, it's important to remember that the Linux desktop has never had a strong focus on security. In fact, the security landscape for desktop Linux is characterized by numerous fundamental issues. We hope to see improvements in these areas in the future. However, for someone whose top priority is security, they shouldn't be using desktop Linux. This isn't to say you shouldn't use it. Security is just one aspect of your computer system. Proprietary operating systems have invasive telemetry and data collection, which make them a bad choice if you're concerned about privacy. While Linux comes free of invasive telemetry and offers incredible transparency because of its open source nature. With that being said, today we're taking a look at a project that aims to at least in part address some of the security concerns of traditional Linux distributions by significantly hardening existing components and systems. Secureblue self-describes itself as a security-focused desktop and server Linux operating system. Secureblue doesn't work like a traditional Linux distribution. Secureblue describes itself as a set of OCI bootable container images, rather than a Linux distro. The Secureblue team says they decided on this setup because, and I quote, "This has meant a ton of overhead is taken care of us by Fedora. We don't need general repos or packaging, except for a handful of specific packages." Secureblue is based on the Fedora Atomic desktop. This differs from standard Linux distributions because it utilizes a read-only file system. This means that every installation is identical to every other installation of the same version. The root file system that is on disk is exactly the same from one machine to the next, and it never changes as it's used. This design provides many benefits. Because the root file system is read-only, it isn't able to be changed during regular use. This results in it being more stable, less prone to bugs, and makes it easier to test and develop. However, it's important to note that users can still override the read-only root file system by defining overrides in the /etc directory, so you are still able to do customization and tinkering. While the project was started by RoyalOughtness, there is a solid group of core volunteer contributors that work on the project and a community of testers and tinkerers. When Secureblue initially released, you were required to install Fedora Atomic and run a command to rebase your system to Secureblue. As of writing this review, they have released installation ISOs, which you can use to install Secureblue directly. This simplifies the installation greatly, and it's especially convenient that they provide different desktop environments and window manager options, along with NVIDIA driver versions too. Security improvements. The main reason to use Secureblue in the first place is because of the focus on security. We would be remiss not to mention some of the key security hardening features that have been implemented. Exploit mitigations. Memory corruption vulnerabilities are extremely common in desktop and mobile operating systems. These vulnerabilities allow attackers to exploit applications to execute arbitrary code. Secureblue replaces Linux standard glibc memory allocator with hardened malloc. Hardened malloc was created by the founder of Graphene OS for use on Android. However, it can also be used on Linux. This hardened memory allocator provides protection by implementing additional checks, monitoring, and defenses to detect and prevent common memory-based security vulnerabilities, including buffer overflows, use after free errors, and heap-based buffer overflows. Secureblue also features a customized security-hardened version of Chromium called Trivalent, which is inspired by Graphene OS's Vanadium browser. According to the Secureblue developers, their browser Trivalent is a security-focused browser based on Chromium. Beyond altering numerous preferences that reduce your attack surface or opt you out of unnecessary metrics and data collection, it also applies patches that enhance security against both known and unknown vulnerabilities, which couldn't easily be obtained by simply checking a box or switching a toggle. Fedora already utilizes SE Linux to enforce access control policies on the system. Secureblue takes this a step further by limiting the creation of user namespaces to processes that are confined by SE Linux, instead of by any process. This means certain allow-listed processes like Trivalent and Flatpak retain the ability to create user namespaces which they require to work, while otherwise disabling that functionality for many other apps, significantly reducing your attack surface. Filling known security holes. Many Linux systems include a variety of programs that always run as the root user by default. This is because these programs have a permission applied to them called setUserID root. Vulnerabilities in packages with setUserID root set on them have led to many exploits on Linux in the past, and any setUserID root package is a good target for hackers to try and find exploits in because of this privilege. Secureblue minimizes the number of setUserID root binaries included with the system, with the eventual goal to eliminate them altogether. This includes removing binaries commonly used to escalate privileges like sudo, su, and pkexec. Instead of sudo, Secureblue relies on systemd's run0 tool, which can provide virtually the same functionality as sudo without the security downsides of setUserID root. Secureblue completely disables support for X11 applications by default. Xorg Server is inherently insecure. One example of many is that it allows two applications running in the same X server to spy on each other's keystroke inputs. X-Wayland enables support for X11 apps within a Wayland session. While it is more secure to run X11 apps within a Wayland session, it can still be exploited when there are vulnerabilities found within the Xorg server. While X-Wayland is disabled by default, it can be easily re-enabled if you do need to use X11-only applications. Secureblue also tries to reduce security holes by disabling commonly abused vectors for malware. Both GNOME user extensions and KDE's theming store are disabled by default. Both of these vectors have been used maliciously in the past as they allow users to install user-generated code on their systems. For example, in 2019, an extension on the GNOME extension store was found to contain an info stealer. Additionally, a global theme on the KDE theme store had an issue where it contained a user script that nuked users' home directories. Security by default. Security is enabled by default, and as such, all ports and services are locked down on the firewall. HTTPS is enabled for all RPM package mirrors, and only verified Flatpaks from FlatHub are enabled by default, reducing information leakage. They also apply some important privacy tweaks that are very important if you're connecting to public Wi-Fi. One of these is MAC address randomization. This means that every time you connect to a network, your MAC address will be randomized, making it harder for your device to be identified when you connect to a Wi-Fi network. Attack surface reduction. Secureblue also implements some key attack surface reductions by removing unnecessary and unused kernel modules, enabling brute force protection for user accounts, and by disabling a variety of services that are enabled by default. Security ease of use. Secureblue also makes it easier for new users to set up full disk encryption with the TPM 2.0 or FIDO2 key unlocking by offering automated tooling to make the process more simple. This process can be quite confusing to do manually, especially for less technical users, so this is a welcome addition to make security more accessible. Additionally, they also have a set of scripts which simplifies hardening of your Linux system by offering commands that automatically apply security tweaks. It's important to mention that we haven't covered every single security enhancement here, just the ones we think are the most important for users to know about. We highly recommend visiting Secureblue's website to see their full list of changes if you're interested in going deeper. Packaging and updates. Traditionally, Linux distributions update by sequentially updating the desired packages. Traditional updates such as those used in Fedora, Arch Linux, and Debian-based distributions can be less reliable if an error occurs while updating. Secureblue differs from standard Linux distributions as it replaces the package manager with a much more advanced alternative called rpm-ostree. The rpm-ostree package manager works by downloading a base image for the system, then overlaying packages over it in a Git-like commit tree. When the system is updated, a new base image is downloaded, and the overlays will be applied to the new image. After the update is complete, you will reboot the system into the new deployment. rpm-ostree keeps up to 3 deployments of the system: staged, current, and rollback. This means you can easily roll back if something breaks in the new deployment. Secureblue recommends 3 different ways for installing packages. Flatpak, the universal Linux package system, is the primary way of installing applications on Secureblue. By default, it uses the flathub.org repository and only allows verified Flatpaks to be installed. While containerized packages remain controversial among Linux users, they offer superior security compared to other options. Flatpak utilizes bubble wrap to sandbox the application, and it also offers a permission system that allows a user to restrict the access of a Flatpak. Homebrew is a cross-platform package manager, commonly recommended on macOS. However, it also works on Linux too. Secureblue recommends using it because it allows you to install CLI packages on your system without rebooting. Homebrew has also recently undergone a thorough third-party security audit by Trail of Bits. They have also addressed the majority of concerns found in the audit. Unfortunately, it still lacks sandboxing on Linux, which is present on macOS. rpm-ostree is the default package manager on Fedora Atomic, allowing the user to layer packages on top of your installed container image. This means that every time you update or install packages through rpm-ostree, you need to reboot your system for them to become active. Secureblue suggests only using this if your package needs deeper system integration or isn't available via Flatpak or Homebrew. Secureblue images. Since Secureblue is based on Fedora Atomic, which has several desktops available, Secureblue has several available desktop options as well. This includes Silverblue, which is based on GNOME, Kinoite, which is based on KDE Plasma, and Ceresia, which is based on the Sway window manager. The great thing about Secureblue being Atomic means that if you decide you want to switch desktop environments, you can simply rebase your system to a different image. Secureblue does mention that there are security implications depending on which spin you decide to choose. GNOME is the only spin which has security protection, albeit weak, against thumbnailer attacks. Secureblue disabled the WL-Roots desktop portal on their Sway spin, which is used for screen sharing, stating that it shouldn't be used because it allows for installed apps to access all the content on your display. Secureblue also has separate images for all of its spins that include no official NVIDIA drivers, Nouveau, NVIDIA closed proprietary drivers, NVIDIA open proprietary drivers with open user space drivers. If you have an NVIDIA GPU, Secureblue recommends you use an NVIDIA driver variant of the ISO, However, whether you use the NVIDIA closed or NVIDIA open variant depends on which generation of GPU you have. What are the downsides? Like with all things when we're discussing security, there are always downsides to enabling more security measures. And because of this, there are some known issues which are currently stopping certain things from working correctly. The main downside to Secureblue is that it comes with maximum security by default. This isn't an issue with Secureblue itself, but app developers have been slow to implement modern technologies such as Wayland and Flatpak. This means you may need to do some troubleshooting with your applications and disable some of the security protections, although this entirely depends on your use case. Memory allocator issues. The hardened malloc memory allocator greatly increases security. While we didn't have any issues with applications functioning correctly, it can cause unforeseen issues with certain applications. Luckily, you can disable it for specific applications if you do run into any issues. Half your CPUs are gone. Secureblue utilizes maximum protections against simultaneous multi-threading attacks. This means if your CPU is vulnerable to SMT attacks such as Spectre or Meltdown, it will be disabled for security reasons. Unfortunately, disabling simultaneous multi-threading can have a significant impact on multi-threaded workloads. However, it's important to note that if you do want to re-enable simultaneous multi-threading, it is entirely possible to do so, and can be easily changed by using rpm-ostree. App images don't work. Secureblue states that because app images require Fuse 2, which is unmaintained and requires the set user ID root permission to operate, they strongly recommend that you use a different packaging format if possible. However, it is still possible to re-enable app images by layering a package that requires it. Should you install Secureblue? Now that we've gone through what Secureblue is, its features, and limitations, the key question remains: should you switch? It comes down to a few factors, which I think are important to discuss. Number 1, you still want to use Linux. This could be for privacy or software freedom reasons. Number 2, you want to have the highest level of security on Linux, specifically. Although it's important to remember, it still does fall far behind alternatives like Android and macOS. And number 3, you are okay with tweaking and fiddling to get certain apps to run correctly. Issues with hardened malloc, Wayland, Fuse 2, and reducing hardening are possible to come up. The great thing about Secureblue is that it comes pre-hardened, and because of the customizability of Linux, you are able to dial back some of the security measures to get it to work for you. However, if you're not familiar with Linux, this might be a bit overwhelming and difficult for you to troubleshoot. If you're already using Fedora Workstation and you're happy with it, but you want to take your security to the next level, we highly recommend giving Secureblue a shot. If you want to learn more about Secureblue, consider visiting their website. They have extensive documentation and information to help you out if you get stuck. Thanks for watching. If you enjoyed this review, consider getting subscribed so you can catch future content just like this. We wouldn't be able to produce videos like this without the support of our donators and members. If you want to support our work, please consider making a donation. See you next time on Privacy Guides.